next speaker, Erik Carlson. Erik, here he goes. Okay, I'll let you introduce yourself. There you go. You just speak a little closer here.
Thank you. My name is Erik Carlson. I'm a PhD candidate at SUNY ESF here in Syracuse in Dr. Andrew Newhouse's lab. I'm going to be talking to you today about an obscure chestnut species called Allegheny Chinquapin. It's kind of the little cousin of the American chestnut. And I've been working on breeding with this species since about 2018. It's kind of a little side project and starting to get a little bit of progress on that. So the Allegheny Chinquapin, it's a native chestnut species. It's like a dwarf chestnut species. It grows with more of a shrub habit than the American chestnut. It has multiple stems. It's a bit shorter. And it also has one nut per burr generally. So it's just one little nut in each burr. And they're very small compared to most chestnut species. It's pretty close to the smallest. There might be maybe an Asian Chinquapin that might be smaller, but it's pretty close to the smallest. So here's some pictures. You can see on the left it's shrubby habit there, and on the right you can see the leaves and the burrs and the nuts. And so these are great for wildlife. They're nice and small for the birds and the rodents and everything else. So at SUNY ESF, we've been working with this OxO gene in our darling trees. This gives us elevated tolerance to blight infection. What it does is it converts an acid that the blight fungus produces into hydrogen peroxide and CO2. That hydrogen peroxide part's important because hydrogen peroxide can actually activate defense genes within plants. So other than just detoxifying the acid, it actually can activate genes within the plant to defend itself. And it's not a pesticide. It doesn't actually kill the fungus, and that will reduce the chances of the fungus developing a resistance to that OXO defense mechanism. So we've begun a backcrossing program. You might have heard that term before. It's a pretty simple process where you make your initial hybrid cross, which is in F1. So we took our pollen from a darling tree and we crossed it with our Allegheny Chinquapin in our field plots. It's a very simple process to test whether or not the offspring have inherited the gene with just a quick little chemical assay. And then from there, we can make back crosses. So we'll take those hybrids that have the gene, take pollen from them, and then cross them back onto Allegheny Chinquapin. And it's a very simple process compared to other backcross programs you might have heard about because we're only selecting for a single gene. We're not selecting for many dozens and dozens of genes using like a highly rigorous process. We just take those offspring, take a punch of the leaf, put it in the chemical assay solution, and that tells us if they've inherited that OXO gene. And you can see this process here. On the left, you can see we use a glass microscope slide to apply pollen. So we take, initially we'll take that slide and we'll rub it across a catkin to collect pollen. And then we can store that either in the freezer or a fridge until we take it out to the field site. And then we'll rub that glass slide onto the female flowers. And then on the right, you can see we'll bag those crosses to protect them from contamination of other pollen types. Then in the fall, this was in 2018, those first crosses, we got our first nuts. And they germinated rather quickly, which is also something that's different with Chinquapins versus most chestnuts. They'll germinate right away in the fall. They'll send out their radicle. And so I got that planted early and grown in January. And then it grew a bit. And then you can see on the right, we took leaf punches, and put them in those chemical assay solutions. And you can see this is a positive test, and this is the negative control. And you can see this black staining around the cut surfaces of the leaf. That's indicating that OXO activity. So it's a very simple process to just throw your tissue into that solution and see if it stains. After it had grown for a little bit, I took a couple of those OxO positive offspring, and I collected some of these side shoots, which is also something different. You don't typically see those in our American chestnuts, but with these Chinquapin, they produce these side shoots, and I put them into tissue culture, and that enabled us to make lots of copies with those. This is also the first time this has been done in this hybrid. I should mention that this is a pretty rare hybrid. You won't find too much literature on this American chestnut by Allegheny Chinquapin cross. So a lot of this is all brand new for this type of hybrid. But I moved that into tissue culture for propagation, which then went through the tissue culture process. It took a little bit of tweaking to get it just right. It's a little bit different than American chestnut, but still pretty close. Took out those shoots and rooted them in peat pellets. It's called ex vitro rooting versus in vitro, which would be in tissue culture. And then acclimatized them in these highly scientific humidity chambers, Chinese soup containers. And then eventually, once they were acclimatized, we moved them out. This is a tissue culture clone you can see here. And then we move those into our highlight growth chambers. So those are growth chambers that have intense lighting from metal halides and high pressure sodium lamps. And that will get you flowering. You can see some flowers here and here and here. That can get you flowering in as little as 1 year. So we're able to speed this process up pretty quickly using these techniques that we initially developed for our American chestnut program. So then we just go back to that process again. We take out our F1 pollen, we pollinate our Allegheny Chinquapin in the field, protect them, and then you've got your first back cross generation. And right now we have done a couple of years of back crossing, and now we have our first back cross hybrids producing pollen for next year, so those will be BC2s. And you can see here, this is an example of the first F1 hybrid that we did between Chinquapin and Darling. And you can see it's growing pretty well. It's nice and healthy. This one is actually a tissue culture clone. So this one came out of tissue culture. It's not a seedling. And yeah, it looks a lot like a Chinquapin to me. The leaves look quite a bit like American chestnut, but the growth habit looks like a Chinquapin. So one of the interesting questions that I had from the beginning is, what are the burr morphologies going to be like? Because on American chestnut, you typically have 3 nuts per burr, and with the Allegheny Chinquapin, it's 1 nut per burr. And so we had our first good crop of nuts from our F1 hybrids last year. One interesting thing that I noticed is that the burrs seem to grow with 2 nuts right next to each other with the catkin in the middle, and it seemed like it was like this on all of them, so that's kind of an interesting morphology. But then looking at counting the nuts, we did see some triples and some doubles and some singles, but for that year it was about 80% of the burrs had a single nut, so they had pretty close to what you would see with the pure species Allegheny Chinquapin. So for future plans with these hybrids, we hope people who are interested in this species would be interested in receiving nuts or pollen or scion, kind of in a similar way that we would like to do with our American chestnuts. These might be attractive options for wildlife plantings, so people like to plant chestnuts for deer plots and things like that, turkeys. This might be a good option for that. It may also be of interest to people who are into breeding chestnuts. If you want to make some complex hybrids, perhaps with these and your other agricultural varieties, this might be a good option. Something else that I thought they might be good for is potentially for like landscape yard trees. American chestnuts aren't probably the best yard trees. They get really large and they produce these giant spiny burrs. These Chinquapin are quite a bit smaller, and they produce less ferocious burrs. The burrs are a lot smaller, they're softer, and they'll attract lots of wildlife to your yard. Another potential could be in dwarfing rootstock. You could potentially graft chestnuts onto these, and I don't know if this will work, but there is some literature about using Chinquapins for dwarfing rootstocks. So the ongoing work is we're going to do continuous back crosses going further down in generations. We're now evaluating the blight tolerance between the pure species and the hybrids and the back crosses. And we're working on getting new germplasm added to our orchard. We've just got a small handful of Chinquapins we've been working with, and we hope to add a few more in the near future. Thank you.
Any questions?